Good morning from a coldish spring morning in South Africa. Everything is growing beautifully. This is the Mine War podcast. Jean Roux, your host, together with MP Strydom. Today we have Gary Rolfe for the final paper and the winning paper that is named Unlocking More Value from Your Project Front-End Loading. Interesting topic. Good morning, MP.
Good morning, Jean, and good morning, Gary. It's good to be with you again. This was a really interesting paper as well, and I'm sure everyone will be happy to learn more about what's going on in your mind, Gary. I heard someone say recently, or ask if they could pick someone's brain, and the response was no, don't pick my brain, but you can pick my mind. So we'll pick your mind today and see what there is to learn.
Gary, good morning. And again, congratulations on winning the 22 papers that were submitted during the tight part of the lockdown in driving our client value and our understanding for it. Good morning.
Good morning. Thank you very much. Good to be here again.
MP, give us a short thumbnail sketch of the competition again, why we did it, how many people participated, etc., for those that have not listened into the previous podcasts.
Yeah, so what it is really about is we know that might not be consultants and mining executives such as Gary, and for that matter, even the IT people, the software developers and so on within MineRP get into contact with many clients very, very regularly. And they kind of develop these ideas as they deal with clients on how we might be able to get more value from the MineRP platform if we solve this problem or that with the platform when they interact with clients. So what we asked them to do was to put their minds, apply their minds to this problem and ask themselves, what would they do if they had an opportunity to solve a valuable problem? And so we called it a value paper competition and asked our employees to put pen to paper and tell us about what solutions they would want to bring to the market. And they were all over the place in the sense that most, as you can imagine, were about solving mining problems, but we got problems, not surprisingly, or I should say solutions, I guess not surprisingly, to address the whole coronavirus issue or medical issues through location-based solutions, etc., because of course the MineRP is a spatial platform. And we got papers about artificial intelligence and machine learning, and we got papers about civil and construction management, which is also a spatial type of solution, and so on and so on. And each of these papers we then considered from the perspective of to what extent we really think this is a valuable, practical idea. And we also looked at them from the perspective of whether or not the writers have identified real key performance areas, measurable value items that could provide value to clients. And that was more or less the competition. We ran it over a period of 4 weeks. And we had about 29, I believe, submissions over that time, of which Gary happened to win 2 weeks, I think the first and the last, and he was also our overall winner.
Gary, we've introduced you to the audience already. You are a mining executive with MineRP. Gary, I'm going to read the abstract that you've written, and then let's dive in. You're saying front-end loading is a process whereby enough strategic information is gathered and utilized early in the project lifecycle to address risks and make decisions. Then you say robust planning early in the project lifecycle forms a vital component of front-end loading. Then you describe the front-end loading stages, and you're saying, why is the mining industry not able to run numerous design and schedule scenarios during front-end loading? Gary, what's the challenge of what we're trying to solve and what you have identified in this paper? And before I hand over to you, what was great about your paper, you also described a case study. So looking forward to dive into that. What's the challenge?
Thank you very much, John. Yes, when I was the principal mining engineer at Anglo American Group Mining, one of my responsibilities was to review projects through all of the phases, from pre-feasibility right through to the execution plan. But it was always clear and evident that we could never ever go through the entire process to evaluate numerous scenarios for the projects. So we always had that question over our head as to, is this actually the best plan that we want to put into place for this project? And the challenge and the reason for that is because mining projects are really lengthy and very resource intensive projects and extremely expensive to boot. To be able to actually go through the entire process of having numerous conceptual alternatives in the pre-fees, whittling that down, as you can eliminate them on various factors, economic, technical, or whatever, it simply would take years and years to go through the entire process properly. The reason being is that we could not produce enough feasible mining layouts and extraction schedules. And that's the challenge faced by the mining industry. And that's why we had to cut corners.
Gary, just before you jump into the details, can I just ask you for clarification? You've used the word scenario, you've used the word alternative. We hear the words options and optimization runs, etc., used often as well. Are those all synonyms in your mind, or what do you see the differences between a scenario, an option, and an alternative?
Option and alternative is basically the same thing. So an alternative is, for example, selecting a different mining method. So does it make sense to go bulk stoping, or do you need to go to a more intensive type of stoping? So that's an alternative. A scenario is then looking at various ways of designing for that specific mining method. So a scenario, numerous iterations of the same mining method, whereas alternatives is looking at something completely different.
Okay, thanks for clarifying.
Let's dive into the solution to this problem that you've personally experienced at Anglo American and later on into the case study. You dive in your paper straight into the tools first, and then you talk about how to apply the tools. Tell us about the term parametric design. What is it? What's the tool? What's in there? And how applicable is it to this paper that you've written?
That's right, John. So unfortunately, it was a little bit too late for me to discover MineRP's parametric planning toolset. But what this does is it allows you to create a mine design, a layout, an extraction schedule, and then it enables you to rapidly go and create scenarios on that by simply being able to change parameters. So when I say change parameters, what I'm saying as an example is interlevel spacing. So I have created a design and I have an interlevel spacing of, let's say, 150 meters. Well, let's see if we can save some capital by making that 170 meters. So I simply go and change the parameters, and the MineRP toolset goes and auto-generates the design again based on what you initially captured for your design, and brings you the result. And it happens in minutes as opposed to days, doing it manually. So once this configuration, as I spoke about, is complete, so you set up your technical design parameters, such as the size of your development ends, taking your geotechnical considerations into account, that then forms the foundation upon which you can go and play and create these various scenarios. And it will also go and change the design for you, but it remembers your extraction sequence rules as well. Okay. And therefore enables you to just quickly go and do a new layout with the same scheduling rules, because those are technical. And it just enables you to go through all those various scenarios a hell of a lot quicker.
Okay. So take us to an implementation example.
All right. So we were approached by, when I say we, I mean MineRP, were approached by a multinational mining company out in North America. And they asked us to conduct a couple of designs for them as a proof of concept on an underground project, which they were currently investigating. What they wanted from us, first of all, was to take on the existing front-end design, which was a pre-feasibility study. They asked us to create an alternative design and extraction schedule, as well as some alternative design scenarios. and they gave us 4 weeks to do this.
Oh, how much time would you have had in your previous career?
To come up with 3 or 4 various scenarios, it probably would have taken us up to a year, 9 to 12 months, because you had to redesign everything over again. So the way we approached the project was that we divided the whole project up into 4 sprints, with each sprint being a week long. So sprint 1, week 1, was the take on the FEL data. So it was the block models, the structural models, the as-built or the survey actuals, their mine design, their extraction sequence, and then their extraction schedule. And we applied some global costs and commodity price assumptions onto that model. So it took us a week to rebuild, as such, their entire pre-feasibility study, design, schedule, extraction sequence, and everything into the MineRP toolset.
The half probably was this EPS template configuration. Take us a little bit into the bowels of that.
Yeah, EPS is actually a pretty amazing tool, which again just adds to the ability to create various scenarios. So EPS is a MineRP toolset which exists inside the MineRP platform, and it basically gives you a Gantt chart view with a couple of indices to look at, and it allows you, within the boundaries of the rules, the technical rules of your design and your extraction sequence, to go and come up with the best production layouts or the best NPV, simply by being able to manipulate the timing and the sequence of your extraction, whether it be your development, your stoping, whatever it is. So EPS allows you to very rapidly have a look at various scenarios, flatten out your production curves, have a quick look at, well, what if we increase production by 5%? You simply go and change that parameter, and you get a new production profile over the life of your project.
And I think the cool thing is that it's linked to the 3D viewer side, and that's just another view of what you're doing. And for the audience, EPS stands for what, Gary?
EPS stands for Enterprise Production Scheduler. And on the point of the 3D visualization, it is almost unbelievable the power of being able to visualize a schedule at the same time that you're busy manipulating it. Because as a professional mining engineer, you kind of know how things should look and when things are going out of sequence. So being able to visualize at exactly the same time while you're manipulating adds a huge amount of value and credibility to your design and your schedule.
Just something that came up to my mind while you were talking is, we're talking about alternative methods and then alternative scenarios. But something that I've heard people say very often is that they get so used to a given approach, especially maybe if it's a brownfields operation that we're doing a study for. Can these parametric tools suggest alternatives which we would have not thought of ourselves, or are they so rule bound that they kind of just will give us a design and a schedule which is the one that we've kind of expected ourselves? In other words, are they just doing our work quicker, or do they also come up with novel solutions, or can we program them to come up with novel solutions?
So, the answer to your question is that the tool allows the engineer to explore as much as possible, and therefore it is the engineer's input into the tool which drives those thinking out of the box scenarios and choices, because it allows the engineer to explore. Within the same time frame that it would have taken him to design one mining methods layout, he could now do several and actually explore and answer all those fundamental questions about what is the right mining method. Is this still the right mining method? And just to go and actually become an engineer and use the tools to drive the creativity.
Good point, Gary. One of our clients, executives, had a statement which we absolutely love and repeat. He said, "We will not have less engineers, but more engineering." I guess that much more engineering is possible. And Gary, take us through an example. I see that in this case study, you refer to 2 things that you did differently. And I guess because you're able to do things so much faster, the engineer is able to think up more things to test. And the first one was the ore reduction by 2 years. And secondly, hanging wall and footwall orientation changes.
That's right. So once we did the take-on of the front-end loading or their pre-feasibility study, looking at it in 3D view, the first thing we discovered was that they had omitted about 17 kilometers worth of development, which had a huge impact on the net present value of the project. So we went and designed in the additional development for them, re-ran it through our NPV optimization engine, just to show them what their realistic NPV of the project would be. So when it came time for us in week 2 and week 3 to start looking at our alternate designs, the first thing we did was, from a pure mining engineering perspective, we decided that the bottom portion of the mine, the mining method which the client had, was probably the best. So we took the top half of the mine and converted it into a mining method which allowed them to access the ore a lot quicker than the mining method that they had designed initially. So we did that, got to ore about 2 years sooner, managed to produce very close to their production profile, and we also managed to reduce the tail from about 5 years also down to around 2 years.
Something that's not in your paper is, did that then pay for the 17 kilometers of development that you found?
No, unfortunately, it didn't. Simply because we had a little bit of extra time. I asked the mining engineer that was doing the design work for me with the parametric tool to look at the orientation of the stopes in the original design and increase the angle to be closer aligned to the actual hanging wall of the ore body. So we moved it. They went and recreated all the stope shapes, and then went and redesigned and scheduled it out. So what was really interesting is that when we moved the orientation of the stopes to be closer to the hanging wall, the waste factor dropped from 26% down to around 11%, but the total ore mined also fell by 13%. And this was very, very insightful. And it was, the change in design was something that the client had been considering, unbeknownst to us. But when we showed it to him and we had the discussion about it, it was, oh, of course, because the shape now included more waste, it made a lot more of the stope shapes unpayable, which we then excluded from the extraction schedule. And that's why the total ore dropped as well. So we answered a question for them that they had been considering inside the mine, and we still managed to do this within the 4-week period they gave us. So we did the FEL, we added the development, we changed the mining method for the top half of the mine, and we went and changed all the stope orientation over for the entire feasibility project.
Gary, this is a value paper, so drive it home. What's the benefits and your conclusion, and what did the client think of this?
Well, the client was absolutely ecstatic, and has realized that in order to get the best value out of their ore body, they need to actually follow the project pipeline a lot more closely, and they can now. Also, you can start playing around with your commodity prices, and because you can rapidly go and change your design and your extraction sequence, your mining business can become more agile and adjust more quickly to changes in commodity prices, whether it's an increase or a decrease in the commodity price. And that kind of flexibility is totally unheard of in the mining industry at the moment. Basically the plan for the year is the plan for the year. Unfortunately, we have to bite the bullet when the commodity price goes down.
And I joked about the 17 kilometers that you added, but I guess this is also, these types of mistakes do creep in because it's complex data sets. And if you can't see it in 3D and step it through the years, it is and easily change it. That's what happens.
I just wanted to finish off with a quote from the client when we had presented all the findings to him. He said, "Think of the value we could add to this project if I could sit next to you, asking all the appropriate business questions, and you could give me all the answers this quickly." And I think that says a lot about the power of the tool and the need to be able to do this kind of rapid scenario generation in the mining industry.
Gary, I think you've been in the right place in the right time to have done this project and be able to write about it. But I think you've added your special touch of your writing style to it, and then your background of realizing that this is special what you've done, having done this before. Yeah, congratulations. MP, what happens from here?
The papers are available online, so you'll find the link posted together with our podcast link on our website, as well as on SoundCloud, where this podcast will be hosted. Gary's contact details is, of course, available at the bottom of the paper as well, so people are more than welcome to follow up with him. And Gary, I'm talking on your behalf here. I assume that much is true, but
Of course.
that's our intention. That these kinds of skills and these kinds of ideas and their creators must get some airtime.
Of course, I'm always available to speak to anybody who would be interested to get some more information and maybe come in and talk to MineRP about doing the same thing for their projects.
And another global client have asked us to do a similar study. We've kicked off a study like this, and this specific client is also following through with further things to be done. This is great and fantastic. That's it. That's how MineRP rolls. And MineWarp, not being a MineRP podcast per se, are interviewing opinion makers. And Gary, I think you deserve to be called an opinion maker. Thank you very much, MP and Gary. Thank you and goodbye.
Thank you for the honor. Thank you. Bye-bye.
Thank you, John. Thank Gary again.